even as the final touches were being completed on our previous version in 2018, new demands were rapidly emerging. RavenDB 5.0 meets these demands by conquering three main challenges: how to manage big data and IoT with a world-class time series model, how to resolve the quintessential document database challenge of having to store keys in your documents over and over and over again, squandering up to 70% of your memory, how to make RavenDB easier to work with to give you more time to focus on building your product. You can now process IoT scale big data with our new time series model that works alongside RavenDB's native key value, document, and graph models. Documents compression reduces your cloud database costs by 10% in slashing storage needs by half. RavenDB 5.0 constantly learns from your data to compress your keys and even your values to save memory and cost at every step. In addition, RavenDB 5.0 includes dozens of minor improvements to make things easier for you while giving you better database performance. Today, Microsoft MVP and RavenDB CEO Oren Eini discusses all the new and exciting features you have in RavenDB 5.0. Feel free to ask questions at any time by clicking the Q&A button at the bottom of your screen, and Oren will be happy to answer them. Enjoy your presentation, and here's Oren.
Hi, everyone. Thank you for joining me. I would like to emphasize what David just said about asking questions. I would absolutely love it if you ask questions during the presentation. I'm trying to present the sum total of a year and a half of work, and I'm trying to do that in a concise manner as possible. So if you're able, or if you have any questions to ask, that would be wonderful to focus me on the most interesting things that I have to show. So we released 5.0 about a month ago, and we had one major theme that we wanted to get out in 5.0. That was time series. Along the way, we effectively accidentally also implemented documents compression, which is still an experimental feature, but it is an awesome feature. I'm going to show some cool stuff about it and show how it works in this presentation. But there's been a lot of other things that we've also done, things that don't deserve a bullet point in the release notes, but may impact your system. So let's go and discover what's in store for us. So those are the big things: time series and document compression. And this is time series. Here we go. What you can see here, this is actually real live data. Well, not live, but this is real data. This was taken from Chicago, and they publish their taxi pickup and drop-off information. And they basically have a 77 gigabyte CSV file. And for the life of me, I cannot understand why they did not zip that or something, because that was a whole waste of bandwidth. But the idea here is that they have a whole bunch of information, but what I actually took from this is, let's just get the longitude and latitude. And I actually forgot to, let me just fix something. I forgot to give the appropriate names. So, location, lat and long. Now, those are just labels, but they would make it easier for me to show you what's going on. Okay, so we have longitude and longitude over time, and that's about it. Now, I've actually shown several cases of time series in the past, and I've actually done a full-blown webinar just on time series. But given that we've released that, I want to show you some of the more cool things that we can do about that. Now, the obvious thing is that we can track a particular taxi over time. We can show you where it was. That's interesting, but only up to a point. Now, something interesting about time series is that it fits very naturally with IoT, Internet of Things, those sort of things, because we are able to give you a tracking of certain values. Location is a great example. Heart rate, blood pressure, humidity, those sort of things. They tend to come from small devices. They tend to come with a whole lot of baggage. Now, one of the things that we have to deal with when we work with time series is the size of the data. Now, in this case, we have about 54 million data points. And that means that if I'm going to look here, you can see that the actual time series that, oh, sorry, on location. The actual data that we need here for the time series is just over 3 GB. So not that interesting. Of more interest for us would be this database. Now, this database contains time series that are much larger. And they include a whole lot of more data. In fact, they include about 100,000 records for each one of these users. And you can see that we have a whole bunch of information. So a time series is able to aggregate data very nicely. Now, 10,000 users, time 100,000 and 100,000, so 200,000. So we actually have 2 billion data points. And here we have 2 data points. Here we have 4. So we have a total of, we have a total of 6 billion data points that we're tracking. Here we have the odometer and the fuel, and a whole bunch of other stuff like that. If we go here, you can see something really, really important. The 6 billion data points that we have are under 65 GB. The reason that I emphasize that is that it changed the game. It changed the game about how much data you can retain. It changed the game about how efficient you can work with the data. All of those sorts of things just become so much easier. For that matter, let's go here and try ask some questions. Let's see what is the, here's the, okay. Average is not a really good example for here, but here's the odometer size, odometer value over time, which you can see there is a very distinct reaction here, and the fuel is basically the same. It's not that meaningful over time. But notice that what I did here, I aggregated the results on a daily basis, and I did that quite quickly. Let's just did that quite quickly over 100,000 records. The way that we stored time series inside of RavenDB means that aggregations like that are really, really, really cheap. We are already doing some aggregation internally, similar to how we do the MapReduce operations. And that means that instead of having to scan to the entire data set, I'm able to do things much, much, much more efficiently. The end result is that even for data sets that contain billions of data points, I can give you the answers in milliseconds. In the previous demo, I actually showed you my heart rate over the 5 or 6 years period that I'm tracking that. And that gives us some, okay, what is my average heart rate per month, per day, those sort of things. And we get the result instantaneously. Now, we do have a problem here. Time series queries operate in the select, which means that they operate after I already selected the documents that I wanted to query. And that's kind of limiting because the way that we model the data is that each document has a separate time series. What even if I want to do something more interesting? I want to ask a question such as, okay, give me everything who was here. Remember, this is the data set from Chicago. So I just drew this polygon. And I want to find, give me everyone who was in this particular location, this time frame. And here's the query that I need to run this. You will notice that I'm doing that using an index. So a major thing that we have here is the idea that time series can be indexed. So let's go and, come on. Oh yeah, I'm in the wrong database. Here we go. So this is the polygon. This is this polygon. And now I'm querying, and here are the results that I'm getting. Now, let's look at the index, which would make sense now. This is interesting. This is interesting because usually in RavenDB, indexes start with docs. Now we started with time series. We're saying I want to index all of the location time series in the texts collection. And I'm getting a particular date range that I'm working on that has entries. And for each one of these entries, I'm outputting a value. I'm encoding the time on an hourly basis. I'm encoding the location using something called geohash, and we'll talk about this in a second. And I'm getting the count. And this is just basically I'm saving none. In here, I'm doing a map reduce. And this map reduce allows me to aggregate over the time and the location. And then I decode the location and get the values here. Notice that I'm using this point here to create a spatial field. This is what I actually queried on before. In here, you can see that this is what I'm querying on. So what's going on here? What's going on here is that I'm running over all of the time series that I have across all time series in the, all the location time series in the taxes collection. And for each one of those items, I output the value where you were in that particular hour. And then I aggregate the results. And I'm done. This is now behaving like any other RavenDB index, which means that I'm able to run spatial queries, which means that I'm able to do all sorts of interesting things. For example, here, all of the taxis that were in this particular location in this particular time. Think how powerful this is. I can use this to figure out, give me everyone who was near me. If talking about COVID, then I want to find anyone who may have been affected by someone who is sick. And that's something that is cheap and easy to do with RavenDB. Something that I said that I would discuss later is this geohash encoding. It's actually kind of hard to translate a spatial location into a value because you have the longitude and latitude. There are all sorts of encoding scheme. I'm not going to get into them, but geohash is something relatively straightforward. It allows me to encode the location into a particular precision. And in this case, what I'm doing, I'm encoding that to precision of 9 characters. That translates to about 25 centimeters or so. So effectively, you're saying everyone who was within 25 centimeters of this particular location get this value. Think about what this means. I can also change things around and say, oh, you know what? This is about 25 meters, etc., etc. So the idea with this is that we're able to aggregate on a rough basis only those who were here within the hour, only those who were within a certain distance. Think about it like drawing grid lines on the map, and anyone who was here in 1 a.m., those sort of things. I'm able to do that because I have the notion of additional sources. And I use this project to compute to encode from the longitude and latitude, the actual location that I have. And there is some logic here that I'm not going to get into, but the idea here is that I'm able to extend RavenDB. We have a question from Muhammad Hassan. Fantastic aggregation over the time series data for location points. Does this feature extend aggregation over multivariate datasets? Can you explain what you mean? Are you asking whether I can do this aggregation over more data points? So if I have if we go to these datasets where I have the location and heading or altitude, stuff like that. And Peter is asking 25 centimeters. You know what? Peter is asking about geohash precision, and I'm not sure. Let's check that. There should be a table here. No. Okay. Here we go. So here we go. So this is in kilometers. So about 20 centimeters. I'm pretty sure this is 20 centimeters. Let me check that. There was a really nice table that I saw a while ago. Oh no, sorry. That's interesting. It looks like 5 meters by 5 meters. Yeah, whatever this is. And Muhammad is saying, yes, more data points. So the answer is that, yes, I can do that over something like this. I have longitude, latitude, altitude, heading, and whatever, and I can use that in whatever form I want. Now, if I wanted to, let's say, take this triad and say, where are you in 3D, I would have to encode some 3D mechanism. I can probably extend the geohash to do the same thing. That would work. But the idea here, with the values that you have up to 32 values, although the recommendation is to use up to 5. And the reason we recommend that you use up to 5 is that we allow you to do additional aggregations. So you can go here to the time series and specify a roller policy. And I can say, you know what, in this case, by, let's say, whatever. Yay. Sorry, I'm using an old license and it doesn't want to show it. But the basic idea is that I would be able to specify this, and then I would automatically get re-aggregated. And for every data point that I have, I'm going to have to track the first one, the last one, the average, the count, the sum, all of those sort of things. And this is going to be managed for me by RavenDB. So instead of aggregating over this raw data, which you can see is every few minutes, I would be able to say, okay, give me the already aggregated results on an hourly, monthly, whatever basis. I can also specify doing that and also specify a retention policy, only do that over a particular time frame. So I want to keep these results for 3 months, and then I only want to keep the results on a daily basis, those sort of things. Okay, let's continue. So those were time series. I intentionally giving you only the highlights. We will post in the show notes also the webinar about the time series itself, and you can watch that to see some of the more usual things. What I'm trying to say, what I'm trying to get to is that we actually have quite a lot of power in our hand with regards to what we can do. We are also able to use features such as multi-map, aggregating time series and document data. We in 5.0 we also have the ability to index over distributed counter values, those sort of things, and make them much easier and accessible for you to use. Okay, so document compressions. We actually got a question about how RavenDB learns to compress keys and how much smaller does the key become. And let's see what RavenDB is doing. Look at this data, and let's talk about what we actually have here. What you see is that we have a schemaless document, actually two documents, and there is a lot of shared information between them. Now, this shared information can be the schema. I have answers here, answers here. All of those are shared across everything. Now, inside a single document, the score that you see here is only stored once by RavenDB because we use the bleatable information. This field, this body field, this is actually compressed because it's a big, it's a blob field. It's a very long string field. So this is already compressed. This is also probably already compressed. That's already built into the data structure that RavenDB uses to store the information. However, document compression gives us an additional benefit. What is this additional benefit? It says, okay, instead of applying those optimizations on a per document basis, let's do them on a global basis. So the idea here is that RavenDB is able to inspect those documents, and it is then able to recognize there are certain repetitions between the various documents. For example, the answers, the ID, creation date, all of those are shared. Those will be the schema of the documents, and they are mostly the same. Not necessarily the same, but they are mostly always repeated. And that can mean that a large portion of your database is actually the schema, the format of the data. But that's actually easy to do. We actually had in in the pre-release, we actually had something like that would give us dynamic schema optimization. We decided not to go with that. And documents compression is much better all around. And let's see what we actually did. Because in addition to optimizing the format of the data, we're now also able to operate over the data. How many times do we have 2013 in the data set? 1, 2, 3, 4, 5, 6. RavenDB, when it learns the compression or we learn how to compress a document, is not going to just look at the schema, look at the format, look at the keys. It's going to look at the entire document. And then it is going to figure out what are the repetitions are. So it is going to actually do cross-document compression. Let me show you how it works. In this case, I'm using, we have a data set. This is called the Stack Overflow data set. It was taken from the public data of Stack Overflow. It's about 52 gigabytes of data, representing, as you can see, about 18 million documents. And then I went ahead and enabled compression. And I enabled, let me see, here we go. I enable compression for those two fields. And let's see what happened. And this is what happened to the system. The size of the database moved from 52 gigabyte to 21. That's less than half. That's significantly less than half. Look at the size of the questions and the size of the users. Each one of them was reduced by a huge margin. Now, this is actually really, really interesting because of the way that we modify the data, the way that we work with the data. So let's talk about this for a second. Let's go here and see. First of all, you can see there is no change in how the data is actually operated. I can use the data as easily as this. I can go here and ask, what is the actual size of the data? And as JSON, this is 4.2 kilobyte. This is the actual size that we have is 3.8, and the size of disk is 1.6. And this is the compression taking effect. What's really interesting about this thing is that you can see that it's very easy to apply compression to just this. But that would lose a lot of commonalities. So RavenDB actually scans a whole bunch of documents and try to find what are the commonalities between them. It then generates a document, a dictionary that it can use to reduce the cost of these sort of compressions. But that leads us to a separate problem. In the Stack Overflow dataset, this is very common during 2012. But once the year rolls down, then we're now going to be in 2013. And the compression dictionary now contains a value that is probably not very useful. So RavenDB actually continuously analyzes the data that we compress. And the idea here is that we're able to recognize when the compression dictionary that we use is no longer the best fit for what we do. In which case, we're going to recreate it. We can actually expose that. You can see here. This is the overhead that we had to deal with to reduce the size of the data by 65%. Someone do the math. I'm talking. I cannot do that while I'm talking. Now, there is no such thing as free lunch. Compression is a typical trade-off of computation power versus space. What's the result in terms of performance for RavenDB? It turns out that while you don't get free lunch, you do get some pretty good dinner for free. And here's how it works. The amount of disk space that we reduce is massive. That means that the amount of I/O that we have to deal with is greatly reduced. Just to give you some idea, the machine that I'm running this on, is here. I got 16 gigabyte on this machine. The data set uncompressed cannot fit into the memory. Compressed, it cannot fit into memory. But the amount of the data set that can fit into memory is much higher, which means that I have to do a lot less I/O. And when I have to do I/O, I have to do a lot less of it. we actually see better CPU, better overall time by spending more CPU cycles, because we don't have to wait for I/O. The cost of I/O is so bad that by compressing the data on the local machine, we are saving a whole bunch of performance. Now, it's important to understand we are doing that on our system, on the local system. We have changed nothing over the wire. That matters because if you have a very large document, you're still going to get a very large document over the wire. Now, RavenDB does compression of the wire if necessary and all sorts of stuff like that, but just something to be aware of. This is not a license to have hundreds of megabytes of documents. And this is great for big documents, and it's great for, surprisingly, for anorectic document, for very small documents. Because in such documents, it's very common that you will have the schema of the document take a significant amount of the disk space. Almost 7 or 8 years ago, there was a blog post that really annoyed me. And he talked about, we're using Mongo, and in order to save on disk space, we're using 2-character field names. And they built an entire object relational mapper on top of Mongo in order to have usable property names, but map them to short property names on the database side. And that never made sense to me. That was never actually a real problem for RavenDB. And now even the theoretical issue is gone, and you get the benefit of compressing the documents on the fly. Other things that are new. One of the most interesting things, I already talked about indexing of time series. You can also index counters, compare exchange values, all sorts of other stuff like that. Those things, we added them not because counters and compare exchange are not stuff that I expect you will often see. You will often see being indexed. Time series, I think you will see a lot, but we added them for completion's sake. So you would have this ability. But I think that one of the nicest features that we have is the notion of optimized range queries over date range. And let me show you what I mean by that. And let's say that I want to ask a question on when was the last access date of a particular user. And second, I actually needed to copy this. Okay. Now I'm going to have to generate an index and the usual things that are happening. But let's see what RavenDB needs to do in order to do this. Or the much more common thing, I have a query that would do something like, or the last 30 days, or anything of this nature. Why does this matter? Let's go to the index. You can see that it's running. Now here are all of the terms for the last access day. A range query inside of Lucene using strings is translated into let's first run over all of this and generate an OR query over each and every one of those. And that can be incredibly expensive when the number of distinct results that I have in the result set is high. Because what it basically does, it does something like this. That's roughly how it actually gets executed. And that's really expensive. And that was one of the more common performance issues that we had with users. In 5.0, RavenDB is actually indexing the last access date. It recognizes that we are working on a date, and it is able to index that using the ticks. And we're going to translate this into another date query using the ticks, which allows us to do a numeric query, which effectively, and again, this might not be interesting to you, but the basic idea is that the performance of range queries has improved by an order of magnitude over large ranges. So that's something that you have to do basically nothing. If you upgrade from 4.2 with an existing database, you'd have to reset any index that has time series data, daytime fields, in order to apply this optimization. But presumably, if you already are using 4.2 and you don't have this issue, because otherwise you would have taken some actions to handle it. This is interesting, the load balancing. I've done here something really interesting. I said use session context for load balancing. And that's it. But this is a very small feature that has huge impact. Let's say that you have an application that has separation, some sort of separation between various users. For example, you may have each users acting independently. For example, you may have each user is running their own accounting, they're not seeing each other's data, those sorts of things. Alternatively, you may have users within a certain group, tenants, company, those sort of things. When I enable this tells RavenDB that on the client side, I can specify a context for the session, which will mean that RavenDB will now take into account the context when doing load balancing. In a cluster that has 3 nodes in the cluster, I'm going to say, okay, all of the users who belong to Northwind are going to use node A as their primary. All of the users who are using a console as their company are going to use node B as their primary. And the idea here is that we allow RavenDB to split the load across all of the various nodes in the cluster, but not have to deal with, I wrote to node A and then I immediately try to read from node B, because I'm giving the client and RavenDB the context to know which server I need to go and talk to. So all of the users who belong to the same context will use the same topology. Note that this doesn't impact anything inside of RavenDB. A write to node B would show up in node A, but this just gives us better control over optimizing the load balancing in the system. Under the hood, we have made some big improvements. One of the major one is that for a very long time, we did a lot of stuff on a per thread basis. So we have a lot of thread local values. It turns out that this is not a good idea in some cases, specifically because some threads are going to go to sleep and not wake up for a while. and a pool that is associated with a thread that is not woken up is effectively leaked memory. We change a lot of that to use per core pooling. That means that instead of, for example, in a typical system, you may have 50, 100 threads. Instead of having 50, 100 pools, we now have 8, 16, 32, those sort of things. Those pools tend to be much more commonly used. So we have a lot less resources sitting around waiting to be used. There's some improvement on JSON serialization. There's been a lot of improvements that aren't world shattering, but have major cumulative impact. Just to give you some example, when you're sorting, when you have a query that uses multiple order by clauses, we have to create a sort array inside of our query engine. We didn't use to cache them. So under certain type of loads, we would generate a lot of garbage because of this, which is an insane thing to do. So we fixed that. We absolutely fixed that and moved it to just pulling them, and the performance for that particular scenario improved by some dozens of percentage points, which is awesome. But this is one scenario, but we've done dozens, hundreds of them. I don't know even how much. One of the things that I'm particularly proud of was we improved the performance of encrypted databases by 25 to 30% by reducing the cost and optimizing what we're doing there. And no impact on the security of the system, obviously, but the end result is that we're in a much, much better location in many respects. Now, I got some requests ahead of time, some questions ahead of time. So let's go and answer them. If you have any questions, please ask them now. That's the right time to do so. So Brian is asking, can you use .NET Core System Tech JSON in Raven 5? The answer is yes, also in Raven 4.2. Now, in order to do that, let's see how it works. Okay. Conventions. There we go. There we go. So this is for bulk insert, not relevant. There was another location. Oh yes. It's really annoying that I can't search for a symbol. So let me, in the meantime, I thought that I had this open, apparently not. So I'm going to defer this, and I will defer this as well. Let's talk about Goran Lokrans. I hope that I'm pronouncing this properly. Moving from XML in Oracle or relational database to Raven. And the answer is that it's relatively trivial. If you need to, you can do a one-to-one transformation from XML to JSON and just throw it into RavenDB. RavenDB will accept that, and you have the ability to query and work and use the data as easily as that. So nothing really complex there. RavenDB has an import wizard to import data from relational database. It doesn't handle a conversion from XML, so that's something that you have to write on your own. But if I remember correctly, the actual process of converting from JSON to XML is relatively easy. the actual process of opening Visual Studio is this easy. Now, one second. Okay. So, not a good place. Let's go entity. There is a way to do that, and I will remember it in a second. Okay. So this should be in here somewhere. Okay. This is what I was looking for. Okay. So here, this is the idea. What you can do, you can implement this and then provide it to RavenDB. This is the one that is implemented using Newtonsoft. You can also do that using you can JSON system JSON text and provide it with whatever you want. There is splittable JSON converter and two-blittable, from-blittable that does the same thing as you need to do. And that's it basically. Now, we have some questions. So Adam Steng, I think, Shentag, maybe. Sorry for the pronunciation. And how long will the experimental features be experimental? The typical time frame is until the next release. So something between 3 to 6 months. Take into account that we are supporting experimental features. The only difference between experimental and non-experimental is that we may decide to make changes to them as we learn from experience in the field. We have Romeo Salayo. User RavenDB interface for running some queries and projection is nice, but users prefer BI client. What is the best way to load RavenDB into BI client like Power BI, Spotfire, Excel, etc.? Well, the easiest way to get stuff into Excel is to ask RavenDB to do so. And you can do that. This gives you an actual CSV and you do something with it. You can also look here into how to integrate with Excel. That's the same thing. There is a guide because you need to do a whole bunch of things within Excel to do so, but this gives you live input from that. Many other systems also give you the ability to run this with a REST endpoint that you can pull the query from, and RavenDB has support to do that. Muhammad Hassan is asking, I see RavenDB is quite well supported for C#. Is RavenDB 5 supported just well for Node.js? What is your take on using RavenDB 5 with Node.js? You can absolutely do that. It is supported, common scenario, no issue with doing this. We are, let's see, I think that the last commit should be from today. Let's see, I think I'm missing something because of, oh, viewer bunch. I'm missing something here because there have been updates. Oh, we haven't merged that. Okay, never mind. So we are in the process of updating this. I think that the changes are here. Okay. So most of the changes are supposed to be here, and we have the 5 stuff or somewhere around here. Sorry, I will have to admit, Marcin, this guy, he's the one who is doing most of the Node.js work, and the answer to whatever you should use RavenDB with Node.js is yes, it's there, it's working quite nicely. The nicest thing about Node.js or TypeScript in general for using with RavenDB is that the data that you use and the language and the underlying database all speak the same language, use the same format, and everything just works quite nicely. Now, Philip is asking about the performance differences of 5.0 and 4.2. And I kept this as the last thing because I'm talking about this thing. 5.2 versus 4.0, 5.0 versus 4.2. This is the Stack Overflow dataset. This is the rough size of the data, 80 million documents. In 5.0 on this machine, so that's 11 minutes and 22 seconds. The 4.2 release, 22 minutes, so about twice as much. Now, this was done without compression. Compressing all of this data took about 21 minutes, which I've done after I've done this. So compression has an impact. I'm not sure how much the speed would have been if I compressed on the fly. It actually might have been faster because I was mostly constrained by I/O where I was running this. But here's another example. This is from our internal metrics. And you can see that this is 5.0, this is 4.2. And here a particular benchmark that we are tracking over time. So overall, the performance of 5.0 is better. I don't think that it's twice as good, but in certain cases, you're certainly going to see significant differences. Most of the things are small changes that accumulate. And this is how you can see the perf difference. And this is what I had to say. I would be very happy to accept any additional questions that you have. So let's give you a few more seconds. And in the meantime, 5.0 document compression, everything is available in RavenDB Cloud. Especially in the cloud, we actually developed document compression specifically because of the cloud, because we wanted to give you a cheaper ways. We reduced the storage space by over 50% to run on the cloud. You can discover a lot of really cool things about RavenDB, how to make your life easy, make your application smoother. You can schedule a demo. This is done by me, by one of our engineers. We take you through your scenario, sometimes with your data, and show you how you can make your application, your system better with RavenDB. The offer is open if you're using RavenDB or if you want to be using RavenDB. I would especially be very gratified if you point other people to us. If you see things, oh, I think that RavenDB would be useful here, give us a call, point that person to us. We'll be very happy to do a demo with them and see if that's something that is feasible. And thank you very much for showing up for this webinar. Goodbye.